Hey, good morning. You know, it's only common sense that things that run true and vibrate less run much better and run longer too. So one of the overlooked things, except for the performance machinist, would be chuck balance. And I've gotten into a lot of things, touched on a lot of things that I do to help me along, and one of them is having true chuck jaws. I don't care how you do it. You know, if you want to make soft jaws, make them all you want. But I use the jaws that are on the chuck because I can hold more things faster, and so that's very critical, is having my chucks in good shape. But I don't want to spend a whole lot of money on chucks, and I got more time and money, so I can rebuild these things and make them work. Now, newer chucks are balanced at the factory, and I've got an example that I'm showing in this video of an older chuck. It's in good shape, but the chuck could be 60 or 70 years old. And newer chucks, they balance. Now, this one was not balanced, and it's quite a bit out of balance. Okay. Now, since I have that set up, I went ahead and I put that bar, that true bar, in this 4-jaw, and I'm just going to go ahead and put it on that truing stand setup and check it out and touch it up if I need to. And I'll do the same with that collet chuck and the 6-jaw chuck. Why not? You know, and it doesn't hurt to have things in balance. And I could definitely tell that there was a problem. I could feel it when I put that 3-jaw chuck on. I could feel the bump. And also, the parts were coming out at 2 thousandths tapered and a little more. And some of the tests and some of the last videos I've done with the 4-jaw chuck and the 6-jaw was better than that. And it should, especially with the 6-jaw. So I think the balancing will help with the 3-jaw. I'll check that out and do a check on that, and also a little bit more checking out for taper problems using the 5C collet chuck. I think people are interested in that. Okay, now so back to performance. I'm going to put a picture of an old motorcycle I used to ride as a '68 Harley Davison XLCH Sportster. And the CH meant competition hot. And I'll tell you what, if you could kick that thing over, you didn't have to prove your bravery in any other way. I hear Chloe out there. Hey Chloe, are you out there? Let's go check her out. How you doing in the sunshine, little doggy? She had a visitor a little while ago. Little puppy named Bill. Hey, yeah, you say hello. Say hello. Yeah. Okay. So back to performance chucking. Hey, you like that, don't you? Okay, we'll be back. Gotta be careful. Okay, we're checking the static balance of this 3-jaw chuck. We're able to do that because I ground the jaws true. And what is in the chucked into the chuck is a ground bar, a precision ground bar that is actually a transmission countershaft out of something, I don't know what. But I use this board to test things. So what I have to do is remove some metal, the heavy parts down at the bottom. So I'm going to follow this circle of holes. I'll scribe a line. And I'm going to start drilling holes. The diameter of these screws are inset on that line until this thing does not do that. I want to be able to put this at quarter turns and even eighths, and it stays. That's enough to cause vibration at certain speeds more noticeably than others. But I don't feel this needs to be dynamically balanced, which spins it and uses sensors at higher speeds. And actually you can balance it at the speed it'll be used with a dynamic balancing machine. But static balance in it is good enough because the highest speed of this machine is 1127 RPMs. And just drilling a little bit of metal out of this thing. So if you set it at a spot like that, it doesn't start rolling on its own. Okay, we'll get that done. You could almost put that on your desk as a decoration, couldn't you? Now, you can refine balancing this statically. I just got this setting up on some precision ground parallels. But the narrower you go until you're to a knife edge, it'll be more accurate. Okay, we'll be back. Okay, you young guys, now let's don't tell these old real machinist guys. The stuff I'm about to show you, this gives you a competitive edge. Thinking outside the box maybe a little bit, huh? Okay, what we're going to do is statically balance this chuck. And I did a earlier video there showing this thing, how it creeps back. Okay, so I found the heavy spot and marked it right here. Now I'm going to take this, you should apply, get training and apply for your permit for a Sharpie Magnum. And you won't regret it. So that was right about there. And I'm just going to give myself a little generous little smear of this stuff here. Okay. Set that aside. Okay, I got a hermaphrodite caliper here. This is one of the very first tools I bought new. And it's just really been great to have. So, what I'm going to do, I'm going to give that just a little bit more this direction. I probably don't need to, but we'll see. Sometimes you have to do a few touch-up holes. So now I'm going to scribe a line that's pretty close, about as good as I could eyeball it, to the center of those screws that hold this chuck together. I don't want to create another line of holes to balance this. And you want to keep your balance holes in a line. And to demonstrate that, put a weight on the end of a string and swing it, then shorten and lengthen the string. That'll tell you why to keep all your holes in a line, or weights added. Now to balance also, you can add weight. and tungsten is one of them. You can get the tungsten slugs from some automotive suppliers. Okay, I got a line scribed here, so we're going to let that slide down the bottom. Oh, I like watching that. It's mesmerizing, isn't it? Okay, we're going to put some balance holes in this thing. Going to lighten it up where it goes heavy. And then we're going to be able to get it so wherever position you put it, it stays. It doesn't swing around like that. Let's slow that down a little bit. Hurry things up. Now I got a little surface gauge here, and I've got a square, and I can look down pretty close. You know, this doesn't have to be, you just want to get it about as good as you can. Now this is static balance, and this is fine for the RPMs that this old Axelson runs. And it's generally good enough for the speeds your 10EE runs. Let's see, generally I'll say. I'm going to slow that down and watch it rock. What side of that pin is that? You gotta be careful to get dust on these too. You know, that looks pretty darn good. I think I got this pretty good with the square. So I'm going to sneak in there with this little devil. I'm going to pull the square up to it though. Okay. Looks like the camera's still going there. Okay, I'll bring that right up to the edge of the blade. And I'll make a mark. Okay, that's the first mark. And we'll roll that back around. And it's clearly visible. Right at about where I put the little, so I know I'm in a good spot. Now I'm going to drill holes the size of these. So I'm going to punch a hole the size of that screw hole there, right there. And I'll set up the drill press to do it, and I'll show you that. Yeah, this chuck here will run about 1/3 the speed of a grinding wheel. And everybody's seen grinding wheels being statically balanced. And we're doing the same thing here. A grinding wheel out of balance has a really a high pitch vibration. A chuck like this out of balance has more of a pulse you can feel in the lathe, and that causes the work to get bigger on the end. So we're going to statically balance this, and I found the heavy spot and I marked it right here. I got a line scribed here in line with the bolts that hold the chuck together, and I'm going to put the balance holes in line with them. And I think I might have described it as swinging a weight on a string, and you can let it out an inch, and it has a different dynamic than pulling it in. So you want to keep balance holes on the periphery and in line with anything that's there. So this is the place to put the balancing holes, and is in line with these holes. Okay, now I still have the arbor through here. It's going through the hole in the table in the drill press, and I can swing the table over. I've got a planer gauge here to support it, and the chuck is sitting on a steel ring on its jaws. You see, that's really a nice setup here for drilling those holes. Okay, So I'll get set up a little bit better and I'll drill a hole here. Okay, got a really nice old Craftsman drill press here. And got it marked. I'm gonna just kind of take my time doing this, I think. I don't know if I can quite reach it. Yeah, I can. Just want to get that started. Okay. I'll get a drill bit in here and we'll drill the hole. Okay, got about the same diameter as those screws here. And I'm going to punch a hole in here and do it by guess, a little bit by guess here. How deep? And if I take too much out, then I have to go around to 180 degrees and remove enough to compensate. And it's not a big deal. Now this is going to run about the third the speed of a grinding wheel. So the balance doesn't have to be as exact, but I'd sure like to get the pulse out. Here we go. Nice cast iron. How's that look? I don't think that's enough, but it could be. Okay, what I'm going to do is I'm going to go back over and check this and keep coming back until I get it balanced, and I'll show you what balance looks like. Okay. We'll call it a performance lathe chuck. Okay, I had to remove quite a bit of metal. These holes here is what it took to get this thing close to balance. You can see it creeping along. Don't want it to go off the end though, I'll tell you what, it'll really crash. See how it's creeping along? It could be drilled a little bit more, but I think that that is plenty good enough. Isn't that cool? Oh! Okay, so this thing, you can install it at just about any spot and it'll stay. See? So it's in good balance. And this is like balancing a grinding wheel. This thing will run about 1/3 the speed. And it had quite a thump to it. I could feel it through the lathe. So I think this is a good improvement. It did take me a couple hours to get it done. Now I had to grind the jaws true, 3-jaw chuck, to get this bar running true. And then we get into the 2/1000ths run out rule that I totally remachined the back of this chuck on the jig bore using a wall hopper and a tree head, but it could be done on a lathe. Refit this, you know, this is a used chuck, it is battered around, so I refit it to the spindle, ground the jaws true in the machine, able to chuck this ground shaft true, then put it on this assembled balance stand consisting of a granite surface plate, parallels, and a couple of angle plates. All leveled out true with a little level. See? Yeah. Okay, that's how you do it. And this should make a good difference in performance. I got not much money in this chuck. I think about 250 bucks, a little less, but I do have a bunch of time in it. Okay, well, I'm going to load this video and maybe just call it chuck balancing. Okay.